Okay, if you could please stop what you're doing and pay attention to the group that's coming up to the board. Present. Okay, so we have these two charges on the line, and part A wants to know, we know what the charge polarity is for Q1, but we don't know for Q2, and we know the electric field in P is 0. So how did you figure out what the polarity was? I see you say it's positive, but how did you figure that out?
So if this one is negative, if this one is also negative, then the field would be 0 in here, but not on either side. But if this one is positive, then that would make it 0 on one of the outsides, depending on which one here.
Okay. Could you draw vectors to figure out where it's 0 to?
Yeah, we kind of did for just that point P.
So which direction would the electric field vector from Q1 be pointing at P? Okay, so therefore the electric field from the other one must be the opposite. Okay. Any questions? That's how we figured out that it's positive. Okay, part B, calculate the magnitude of the charge Q2. So how did you go about figuring that out?
Just KQ over R squared, and you set them equal to each other.
So what are you setting equal there? Is that the potential? What is that?
No, that's not.
What is it? The E field. Okay, setting the E field equal. Okay, and notice they did not put the polarity in for the E field. There's no polarities for the E field. Set them equal, and they solved it, and you guys got what?
4.8 essentially negative 8.
Any
It
questions?
makes sense because it has to be bigger in order to get 0 over there.
See what it says? Any questions? Okay. And then part C, calculate the magnitude of the electric force on Q2 and indicate its direction. So how did you go about figuring that out?
Well, we did the forces K1, Q2 over R squared, and we forgot to do the direction. But wait, Q1 is negative, so this is really that one.
The magnitude and direction on Q2. So which way did you say? All right. Any questions? And then part E. Part D. Determine the x-coordinate of the point on the line between the two charges at which the electric potential is 0. So how do you go about figuring that out?
So you use the potential, and so KQ over R is equal to KQ over R, but one of them is negative to begin with, and so you have to subtract over, and then get rid of the negative because the charge is going to be negative on negative 1.
Okay.
And plugging on numbers.
What did you give for that one?
Negative 0.082 meters.
Okay, negative 0.082 meters. I have a question. Is that the only place where the potential is 0?
It's the only place between the two charges.
Okay, question.
Why did you use 0.3 instead of 0.4?
Because these two charges are only 0.3 apart. Q2 is 0.4.
Yeah. Also negative from where? Like, what did you say?
We use this line up here, so negative from.
Any questions on that? Okay, then part E, it says, how much work must be done by an external force to bring an electron from infinity to a point at which the electric potential is 0? Explain your reasoning. So what do you guys say?
So we said where the electric potential is 0, so that's 0, and the voltage at infinity is 0, so the change in voltage is 0, and therefore work is also 0.
Any questions? Okay, give me a hand, thanks.
I have a question about D. Do you only have to find one, even though there could be one?
Yes, and the reason why you only have to find one, can you guys explain why you only have to find one?
The problem says you only need to find the one in between the 2 points.
Yeah. Where would the other one be at? Would it be on, would it be closer to the smaller charge or closer to the bigger charge on the outside?
Closer to the smaller charge.
Closer to the smaller charge on the outside, yes. Okay, could you please now work on B3?